Let me talk about the graph of a logarithmic function. First, let's think about the graph of an exponential function because they're closely related. Y goes to 2 to the x. You can make some table of values for it, x and y, -1 and 0, 1. Let's just do these three values. Anything to the 0th power is 1, so 2 to the 0th power is 1. 2 to the first power is 2. What's 2 to the -1 power? 2 to the -1 power is 1 over 2, so that's like 0.5. Okay, what does that give us for the graph of the y equals 2 to the x? Well, let's see. At 0 it's 1. At 1 it's 2. And at -1 it's 1/2. So you have a graph like this. Now as you go to the right, 2, 4, if you square 2 you get 4, and then it just goes exponentially. This goes really fast. And if you go left, because you're taking negative exponents, it becomes closer and closer to 0. So this x-axis actually happens to be the horizontal asymptote of this graph. Okay, now using this we can think about the graph of y equals to log of 2 of x. We already introduced the fact that log 2 of x and 2 to the x are inverse functions. What happens to the graph of an inverse function? Well, inverse functions are obtained by switching x and y. So if you switch x and y, that gives you that's like flipping the graph over the diagonal line, which we call y equal to x. Right? If x goes to y and y goes to x, that's like taking the sheet of paper and switching it so that it's flipping over y equal to x. Now one of the effects of that is that instead of having a horizontal asymptote, a horizontal line, when you flip it like this, becomes a vertical line. So instead of the x-axis becoming the horizontal asymptote, the y-axis is now the asymptote. It's a vertical asymptote. And as this goes closer and closer to 0 this way, if you flip over this side, then this will fall over here. The entire second quadrant will fall over the fourth quadrant if you flip it over. So this thing will now become this. And what is this coordinate here? This is 0, 1, right? You have 0, 1 here. And therefore, when you flip x and y, the x and y coordinates change, and this coordinate becomes 1, 0. Okay, and then the first quadrant, which is going away from the diagonal this way, well, when you flip it, it will go away from the diagonal that way, so it's going to go like that. That's the graph of y equals to log 2 of x. Now in general, graph of y equals to log a of x, with a being bigger than 1, looks like the following. It will always pass through 1, 0. It will always have the vertical asymptote at the y-axis, so that when log is taken to x goes closer and closer to 0, it will go down all the way down to -infinity, and then if you go right, it's going to bend this way. So that's the graph of y equals to log a of x in general. Now, there's one thing that's really important when you look at this graph. You have to notice that the domain of this function is from 0 to infinity. You can't plug in negative values to a logarithmic function, and the range will be all reals. So this is the graph that you should memorize. You should memorize that any y equals to log a of x with a bigger than 1 will give you the x-intercept 1, and vertical asymptote is the y-axis, and it's going to have this shape. Now what if a is less than 1? That's not too important, but let's do that anyways. So first of all, if you have y equals to 1/2 to the x power. In this case, when you take the 0th power, it's 1. When you take the first part, it's 1/2. And if you take the second part, it's 1/4. So instead of increasing as x increases, it decreases. And when x is negative, then -1 is the reciprocal, which is 2. And it's actually the negative direction where it increases. Again, you have the horizontal asymptote as the x-axis. Therefore, when you flip it, the inverse function of this function is log with base 1/2 of x. So if you flip it, the horizontal asymptote will become a vertical asymptote, and since the first quadrant will still stay as first quadrant if you flip this over the y equal to x, the diagonal line, you would expect that the graph will get closer and closer to the y-axis as it's increasing, going up. So it's actually like that, where this point is still 1, and it bends like this. If you think about how this flips over, this thing flips over here, and that's the graph that you get. So that's the shape of the y equals to log a of x in general when a is less than 1 but bigger than 0. If a is negative, then the logarithmic function is not defined. Log a of x is only defined for a value of a bigger than 1 or less than 1 but positive. So in general, the graph of y equals log a of x when a is less than 1 looks like this, but it passes through 1. That's the basic graph.